Let's start with a simple question every bank and trader secretly worries about. How much money could we lose if markets suddenly move against us? That's where value at risk, or VAR, comes in. VAR gives us a clear numerical answer by estimating the maximum expected loss over a certain number of days and at a chosen confidence level. The formula is straightforward and practical. Portfolio volatility multiplied by as a score and multiplied by the square root of time. I. For a 99% confidence level, alpha is about 2.33, meaning losses should exceed our estimate only 1% of the time. Notice something important. If volatility increases or if we hold positions longer, risk grows quickly because of that square root of time scaling. Now imagine we're not holding just one asset but two assets together in a portfolio. Suppose we invest $10 million in asset A and $5 million in asset B. Each asset has its own daily volatility. Say asset A moves about 1.9% daily and asset B moves about 3% daily. But risk is not just about individual movements. What really matters is how these assets move together. If both rise and fall at the same time, losses stack up. This is called positive correlation, and here we assume a high correlation of 0.8, meaning they move mostly together. When correlation is high, diversification benefits disappear and the portfolio becomes riskier. When correlation is low or negative, losses in one asset can be offset by gains in another, which reduces total risk. To capture both individual risk and shared movement mathematically, we use something called the covariance matrix. First, we square each volatility to get variance. For asset A, 0.019 squared gives 0.000361. For asset B, 0.03 squared gives 0.0009. Then we calculate covariance using correlation times both volatilities, which gives 0.8 times 0.019 times 0.03, or 0.000456. These numbers form a matrix where the diagonal shows each asset's own risk and the off-diagonal shows how they move together. Think of this matrix as the DNA of portfolio risk. Next, we represent our investments as a vector, beta equals 10 and 5. This simply tells us how much money is allocated to each asset. Bigger weights mean a bigger contribution to total risk, so asset A naturally has more influence. We now perform matrix multiplication. First, multiply the row vector by the covariance matrix. Column by column, we get values 0.00589 and 0.00906. Then multiply this result by the column vector again. That gives us 0.00589 times 10 plus 0.00906 times 5, which equals 0.1042. This number is the portfolio variance. Taking the square root converts variance into volatility, so the portfolio volatility becomes the square root of 0.1042, which is approximately 0.3228 or 32.28%. That means on an average day, the portfolio may fluctuate by about 32% of its value. Quite large because the assets are strongly correlated. Finally, we plug this volatility into the VAR formula. VAR equals 0.3228 times 2.33 times the square root of 10 days. The square root of 10 is about 3.16. Multiplying everything together gives roughly $2.38 million. So with 99% confidence, the worst expected loss over 10 days is about $2.38 million. In other words, only 1% of the time should losses exceed this amount. But banks don't stop there. Regulators require an extra safety cushion. Under the rules set by the Basel Committee on Banking Supervision, banks must hold capital equal to at least 3 times the 10-day VAR. So if VAR is $2.38 million, the bank must keep about $7.14 million aside as protection. This ensures stability even during extreme market stress. So the big takeaway is simple and powerful. Individual volatility creates risk. Correlation amplifies or reduces it.